Hello and welcome to this demo pitch video on IxNetwork OVSDB solution. Today in this solution, I'll tell you how you can use the Ixia OVSDB solution to test a TOR in a data center environment. To start with, this is the topology. On the left hand side, you can see there is an OVSDB controller, and then there are hypervisors and VMs, as well as a very special element called replicator. On the right hand side, you have a TOR, and behind the TOR, there are a couple of bare metal VMs are attached. So the controller will configure the logical networks on this TOR that will enable the TOR to receive and forward the packets received from bare metal VMs to the hypervisors. The controller will also create the UMR entries for the VMs here behind the hypervisors. The replicator here is a very special kind of a hypervisors and plays a very important role in handling the BUM traffic. So BUM is a short for broadcast, unknown unicast, and the multicast traffic. So what really happens is that whenever a unicast packet is received by the TOR, it will send it directly to the hypervisor. But when it receives BUM traffic, it will send it to one of the replicators. So usually in the network there are more than one replicators to handle the resiliency and stability. So this TOR will send the BUM traffic to replicator. Replicator will replicate this BUM traffic to the correct hypervisors, and then the hypervisors will handle the packet accordingly. One example is the bare metal VMs are sending an ARP request for the VMs. So the ARP request is an unknown unicast traffic, and it is sent to the replicator. The replicator gives it to the right hypervisor. The hypervisor will forward it to the VMs, and the VMs send a unicast reply through this hypervisors to the TOR. So this is how ARP requests are handled in this solution. So now let me go to the IxNetwork and show you how this is configured. So I'm starting from scratch. I'll add a topology for the controller first. So this is my port. And here I will, under the category SDN, I will select OVSDB controller and finish. Now, as you can see, there are multiple devices here, and this is so far the most complicated topology we have, which is simulated on a single port. So let me first name all the elements here. So this is a controller. This is a hypervisor. And this is a replicator. And this is the VMs behind the hypervisors. Now let me configure each and every element. Let me start with the controller first. So let me configure the controller IPv4 here. The gateway IP here is the IP of the L3 interface through which the controller is connected. So controller is, as of now, we cannot connect the OVSDB solution directly to a TOR. We have to use a layer 3 network in between. The reason is we are emulating multiple elements here on a single port, and for all the ports, for all these devices, there's only a single interface which is connected, which is the controller, and hence we just give a IP of the interface which is connected to this port. In our case, this is 192.168.1.1. Okay. Now let me next configure the OVSDB controller itself. As you can see, it works over TCP, can also work over TLS. If you select TLS, then you have to also give the certificate files and the key files. here. I'm leaving the TCP port to be 6640, which is the port mentioned in the standard, but you can change this value. In the last, there is a value transaction timeout. This is only used when you're using a scaled setup. Since this is a small setup, I am not going to change the value here. Next, I'm going to create a couple of logical networks. For that, I'll go to this tab, cluster data, and I'll change the number of bindings. So bindings is nothing but number of logical networks that you want to create here. So, so the very first thing I want to do is change the VNI here. So I've got two VNIs, 5000 and 5001. And for these VNIs, I'll change the logical switch name. The physical switch name is the name which is there on the TOR, and this has to be used as it is on the TOR. On the TOR that I am using, the logical IP is the management IP, and it is 10.200.224.199. Also, the physical port name is as the port names on the TOR. So my physical port names on this TOR is TE1/1. Okay. And then I have VLAN ID. So I've got two logical bindings here. One is mapping VLAN 1000 to 5000, and another one is mapping VLAN 1001 to VNI 5001. So my controller configuration is done here. Now next I'll move to my hypervisor. So I'm going to only use one hypervisor, and I'll change this. When you change this value, the multiplier here will also change to accordingly. Now here I am going to give the IPv4. As I told you, only the controller is connected to the L3 network. The hypervisor IPs and all are not. So you can give any IP that you want. In my case, I'm going to give 172.17.1.1, and the gateway IP is 172.16.1.1. So the L3 network will have a route for these tunnel endpoints. Next, I'm going to configure the VXLAN. So I have two logical networks and two VNIs. So I want to have two VNIs. So I'm just going to change the multiplier here and make it 2. So my tunnel here and the VNI is configured now. Now there is another important thing I need to do is enable unicast information, and this is required to forward the VM packet to the unicast destination. So usually this is the TOR IP. So I'm going to give here in this tab the TOR IP, which is 172.16.1.1 in my case. So now I am done with the configuration for my hypervisors. Next, I am going to configure the replicators. I'm just going to have two replicators. And let me configure the IP of the replicators here. So I've got two replicators, .101 and .102. So the TOR is going to select one of these two replicators for per logical network. Usually the TOR will select the same replicator for both the logical networks, but it may select differently also. So my gateway IP here is the IP of the TOR. So this is the TOR tunnel IP 172.16.1.1. So my replicator IP is not configured now. Now I'm going to configure the VXLAN tunnels for this replicator. Now since replicator is a very special type of hypervisor, and apart from handling the logical network, it is also handling the BFD. The BFD packets are sent over VNI 0. So basically the replicator is running 3 tunnels, 2 for the logical network and 1 VNI 0 for the BFD. So I'm going to set the multiplier to 3 here. And I'm just going to configure the VNIs accordingly. So I'll use the custom here. And change one of the VNIs to 0 here. So now I have got 3 VNIs here, 0, 5000 and 5001. Okay. So my tunnel configuration for replicator is done. Next I am going to configure the BFD for this replicator. So the first thing I need to do is aggregate BFD sessions. What this means is that for all the VXLAN tunnel, it is going to run a single BFD session over VNI 0, and that's why you will see that only the BFD session over VNI 0 is active. All the others have been unchecked. Here you also have number of sessions. The number of sessions is basically the number of BFD sessions that each replicator has to handle. Each replicator will be running at least one session with each TOR. So if in my case, since the number of TOR is only 1, I have only one session here. If you have multiple TORs here, so you have to increase the number of sessions accordingly. And you can also change the min RX interval and TX interval. This is to configure the interval between the BFD hellos. Next, I'll configure the Bfd V4 session. Now for these tunnels to be operational, they also have to do OVSDB communication. That is, this replicator will actually update the tunnel entry on the TOR and make it BFD enabled. Then only the BFD session between the replicator and the TOR can be run. So now my configuration of controller, hypervisors and replicators is done. Now let me add some bare metal VMs here. So I'm going to add simple IPv4 stack. Let me first change the name of this device group, which is bare metal VMs. And I'm going to change the count to 2. I'm going to have one bare metal device for each logical network. Now I have to configure the VLAN on this bare metal VMs. The VLANs will be as the logical bindings. So I have got two bindings here for VLAN 1000 and 1001. Accordingly, I am going to add and configure the VLAN here. So here VLAN and VLAN 1000 and 1001 as per my bindings. Okay. Now next I need to do is the bare metal VMs, and the VMs, they are in the same network, so I have to match the IPs of the bare metal VMs and the VMs. So here the IPs are 102.1.0.2 and 102.1.1.2. So I'll configure the same on VMs. Here again I am going to have number of VMs as 1. So since there are 2 VNIs, for each VNI there is 1 VM, and correspondingly you have 2 VM devices here. So I'll go and configure the IPv4. I will uncheck the resolve gateway because it is not required. This is because the VM will learn the IPs of the bare metal using the OVSDB communication. Now I'm going to configure the IP here for the bare VMs and the bare metal. So this is 102.1.0.1 and this is 2.1.0.2 for the bare metal VMs. So now all of my configuration is done. Now let me start this topology and bring it up. So first thing I will do is I will start my controller. and I'll wait for bindings to get to attached status. So if the information that I have given here is alright, then my bindings will go to the attached status. So now they have gone to the attached status. Now I can go and configure the other elements here. So now next I will start is my VMs. That will also start the hypervisors in front of them, and they have come up. Now next I will start the replicators. Takes a while for the BFD tunnel to come up. So now the BFD tunnel has turned green, so my replicator is also running up and running. Now before I start my bare metal, let me start the capture. That is because I want to see that when I start my IPv4 stack and it does ARP resolution, how is that ARP resolve? So I will go to the capture and I'm going to enable the controller. Let me start the captures here, and let me start the bare metal devices here. If all my logical bindings are correct and the bare metal VMs and the VM IPs are correct, then these bare metal VMs will come up. As you can see that they have turned green here, and the ARP is resolved, and it knows the MAC of the VMs here. Now let's take a look at how this ARP has been resolved. So let me filter for ARP packets here, and these are the ARP packets that I am looking for here, and this is sent by the bare metal, and it is sent to the second hypervisor for the VNI 5000. So the Tor is using the second replicator .102 for sending the bump traffic for logical network with VNI 5000, and then this request as received by replicator then given to the hypervisor, and this is the hypervisor which is replying. As you can see, this .1 is my hypervisor. It is sending it directly to the Tor for VNI 5000. Similarly, for the other bare metal VM, you can see this is VNI 5001, and the Tor has selected the second replicator as the designated replicator and sent it to that. And here this is the reply which comes for directly from the hypervisor as a unicast to the Tor. So this is how an ARP is resolved on a bare metal VM. Now there are some statistics that you can look at to see if there had been any errors. So you can take a look at the OVSDB controller stats here. I have OVSDB controller purport stats, and it shows me that no errors have been received so far. It gives you also the number of JSONs that have been sent, and if there had been any invalid JSONs that are received. You can take a look at the Bfd configuration, and here you can see the remote IP over which the Bfd session is running. And here in the VXLAN, you can take a look at the learned information, which tells you the information about the bare metal. So if I do a get VXLAN learned information, it'll give me the bare metal IP here. So this is the bare metal MAC, and the remote VTAP through which this bare metal can be received. The remote VM IPv4 is optional, and different Tor give different values for that. Sometimes it's 255.255.255.255. In some cases it is 0.0.0.0, and some of the Tors also return the VTAP IP itself as the VM IPv4. Irrespective of that, the tunnel entries are right, and the VM MAC and the VTAP IP through which this VM can be reached have been correctly retrieved here. Similarly, you can see the VXLAN learner information here as well. And this is for VNI 5001. This is the second bare metal VM and the VTEP IP. Thank you for watching this demo. And just as a summary, I have covered how you can bring up the data center topology using Ixia OVSDB solution, and how you can resolve the ARP on bare metal VMs.